so I don't block anybody. But I feel really close. Where's the camera? Welcome to another episode of Unboxed Dev Talks. This month we are our guy right here, Hayden Braxton, our software engineer here at Unboxed Technology. He is the mastermind behind these Dev Talks as well, which is pretty cool. But he is going to be talking today about Docker, a little intro to Docker. And we're going to go ahead and make a plug for next month. Our very own Philip will be talking about bouncy castles. So, do you just want to give a really quick plug?
Yeah, sure. So my talk's going to be about implementing PGP encryption in C# using the Bouncy Castle library.
Cool. And
it's the best library name ever.
I know, right? Well, J5 is pretty cool too. Also, if you notice down here, aside from our YouTube stream and Google Hangouts, you can actually join us here in the office in Richmond. If you click that link, it'll bring you over to the Eventbrite where you can RSVP. So come join us. We're in our new location still, and it's awesome. And I'm so close to this camera right now. All right, so without further ado, I'm going to pass it over to Hayden, and he's going to tell us some more about Docker.
Awesome. Thank you, Patrick. So like Patrick said today, we're going to give an intro to Docker and all the fun things that we can do with Docker. Docker itself is only about 5 years old as a technology. It's only been around for that long. But even this past 5 years, it's become quite popular, and a lot of use cases have come out of the containerization technology since then. So we're going to take just a very introductory look at what Docker is, why it was created, and what we can do with it. So before we get started, if anyone is following along with the examples, or if you plan on going along with the examples later on, you will need Docker installed. So you can either install the Docker Community Edition, so you can install Docker for Mac or Docker for Windows. However, if you have an older desktop, you might need to install Docker Toolbox, which is the second link there. So for example, Docker for Windows only runs on Windows 10 Professional. So if you're on Windows 7 or Windows 10 Home, then you'll need to use Docker Toolbox. But the user experience is pretty much the same either way, so it's all good. And also, if you are on a Windows machine doing these examples, you'll need to make sure, or if you're on Docker for Windows, you'll need to make sure that you have switched to Linux containers, and we'll kind of explain what that means as we go along. Also, there's going to be a code example. You can get that here. This link will be in the description later on. So quick agenda about what we're going to do. So first, we're going to start talking about why Docker was created, and then talk about, okay, so what is Docker even? I think Docker is kind of up there. Docker and containers are kind of up there in the technology community's most popular buzzwords of the past few years. Then we'll talk about, okay, what is a container? We'll talk about what's an image. So containers and images are kind of the basic building blocks of using Docker. And then we'll talk about, briefly, the Docker engine, which is kind of the guts under the hood that's making all of Docker work. And then we'll finish off with some examples. And actually, examples will take up most of our time. Some of our examples will include running containers. We'll build an image. We'll kind of we'll look at a few advanced use cases of containers, talk about some use cases, and then take a small peek under the hood of what Docker is doing for us when we run containers. And then lastly, we'll finish off by talking about, after we have this introductory knowledge, what can we do next with Docker. So quickly about me, I'm from Richmond, Virginia. I'm a software engineer here at Unboxed Technology. Most of my free time, I spend playing with JavaScript and Docker. That's what I call fun. And then I love me some Indian food, so if you give me some Indian food, I'll be your best friend for life, or at least for the day. And you can follow me here on Twitter. That's my Twitter handle at the bottom there if you want to. So starting off, why Docker? So why was Docker even created to begin with? And so there's two main problems that Docker was created to solve. So those being one, efficiency, and the second, consistency. So we'll start off talking about efficiency. So back in the day, whenever you wanted to host an application on a server, it was just one application per server, right? And so what ended up happening was there ended up being a lot of wasted computing resources. Typically there would be just one whole server that was only running one application, and that server itself could have done a lot more, but people tended to be a little more precautionary and buy bigger servers than they needed to, right? And so it was kind of a shame. There was a lot of manual work done in having to maintain those servers, a lot of waste of time, money, and personnel, and everything was just much harder to maintain. So there's a lot of waste, not very efficient. And then later, at some point, virtual machines came along, and this is kind of how things look these days, right? So these days, what we do is we can run multiple applications per server, just in a virtual machine, or maybe you just have multiple virtual machines itself running in the cloud somewhere. And we're not so much concerned about the server itself these days. We're more concerned about the virtual machines. So instead of having just one operating system and application per server, you could have multiple virtual machines, each with its own operating system, and each running its own separate application to make sure that that application was kind of insulated from the rest of anything else that was going on that server. But this still isn't the perfect world, because having to run multiple virtual machines and one operating system per virtual machine was a lot of wasted resources even still. So because just having, regardless of the applications that you're running, just having that operating system itself run and the virtual machine itself was a lot of load on the server, even without having that application running. So, better solution, and that's how most of us do things these days. But still, some people started thinking, well, can we do any better? So then came along the idea of containers, and Docker wasn't the one to start containers. Actually, containers started, the development of containers started in the Linux world, but Docker kind of picked it up and ran with it and moved that technology forward. So now, instead of having multiple virtual machines and multiple operating systems per server, you could have just one operating system itself running on that server, and then per application, you would have a container, as it's called, isolating the application from the rest of the environment on the operating system itself. The machine you have down here at the bottom itself might be a virtual machine in the cloud somewhere, a virtual machine on premise, or it could just be straight on the bare metal itself. Either way, you just have to have one operating system, and then you can run however many containers you want. And the value of having that container is that, so the container, instead of having to have its own operating system, it shares the operating system of the Docker host. So this server down here would be the Docker host, and then each container here, any operating system needs, it can just share it straight from the host's operating system kernel itself. So furthermore, that creates a lot more, just a lot more efficient use of resources. Having these containers, they're much more quicker to start up and to spin down than a virtual machine itself. And then, so just all around it's a much quicker experience. This allows for better horizontal scaling, so you can have more instances of your application per machine, which allows you to have more availability. So having this kind of setup opens up a lot of possibilities for us. So that's kind of the high-level story of efficiency. The next reason why Docker was created was for consistency. So this is a common problem in software development, right? When you develop something on your machine, it works just fine, and then when the next developer pulls it down, it breaks, or when you push it to the server, it breaks. And so, the irresponsible developer would just be, well, screw it. It worked on my machine. That's the only thing I have control over, and then move on. But all of us here, I assume, are responsible developers. And so, we have to go through the pain of, okay, why did it work on my machine? What's different on that person's machine? And so what ends up happening is we end up, each developer has a different setup, and then the servers that our applications are running on themselves have different setups. Docker allows us to develop, ship, and run our applications all in the same way, in a much more consistent way in each case. And it also, as I mentioned last time, having containers, we can easily spin up more instances of the same application, which allows for more availability in the case that maybe one of the instances crashes. Well, we still have 5, 10, 100 other instances, and the end users don't notice any difference. So now we talked about, okay, why was Docker created? Well, what is Docker itself? So the Hayden Braxton definition of Docker is the following. So Docker is a virtualization technology that allows you to create isolated, minimalistic environments that contain only the absolute necessary dependencies needed for a specific purpose. And that specific purpose itself might be running a particular app or service, or maybe just performing some admin tasks on your own machine itself. So Docker, however, is both a technology, it's an open source technology, as well as a company. So Docker as a technology came out of a company called .cloud about just over 5 years back. .cloud was hosting applications for other people on AWS, and Docker kind of came out of the secret sauce they were using to host other people's applications. Then they realized, hey, like this thing is where it's at, and so then they released their container software as Docker, and then rebranded themselves as Docker as a company. However, Docker, while they've done a lot to push the container technology forward, it's not the only container platform out there. So there's others. So for example, there is Core OS is another containerization platform, and there's plenty of others out there. There's also the concept of native Linux containers. So these days there is what's called the Open Container Initiative, which was again spearheaded by Docker, but people from Microsoft, Google, Red Hat, and other organizations are part of this initiative to kind of define industry standards around containers, container runtimes, so that no matter what platform people are using, they can integrate and work with their containers in a similar fashion. Now, it's interesting kind of where the name Docker came from. So the name Docker got its inspiration from the shipping container industry. So a couple hundred years back, when shipping goods across the ocean, they would just load up ships in whatever way they wanted to, and it was much more of a pain, right? Because the person shipping goods, not only did they have to be concerned about what they were shipping, they have to be concerned about how it was being shipped, right? So if I want to ship, say, some coffee, right, I've got to be concerned about what ship it's going to be on, what else is going to be on that ship with it. And then they kind of got together and agreed upon some standards. Okay, so then they said, we're going to start using these shipping containers. They agreed on the dimensions of these shipping containers. They agreed on how they're going to build the docks, how they're going to build the cranes. So that way, the person shipping their goods only had to be concerned about what they're shipping. They don't have to be concerned about how it's being shipped. They just know it's going to go in this container, and then I or someone else can show up on the other end and then pull out the same stuff that I put in the container. And more or less, it was going to be a much more consistent experience. And then likewise, for the people shipping the goods, they didn't have to be concerned about what was inside anymore. They only had to be concerned about how to ship the goods. So it really separated the concerns there for the shipping industry. And Docker does the same thing, right? Because now, what Docker allows us as developers to do is, if I'm just a developer, I'm not worried about shipping code as much. I can just be concerned about, okay, what the code is, what's going inside of my container. And then, suppose, here at Unboxed we don't have DevOps, but if we did have DevOps on a larger team, the DevOps people aren't concerned as much about what exactly the code is, what it's doing. They just want to know how to ship it, right? So Docker really provides for us that separation of concerns. And just on another note, on a follow-up note, why should I learn Docker? So this quote comes from Gartner. So it says that Gartner predicts that by 2020, more than 50% of global organizations will be running containerized applications in production, which is up from less than 20% today. So we can use Docker to run our applications in production. But some people may only ever use Docker in development, and that's fine. So here at Unboxed, we don't use Docker in production. We use it or a couple use cases just for development purposes. And so for some companies, they might pick up Docker and be like, hey, you know what, this is the new thing, this is how we're going to run our applications in production. And that's cool. But then for others of us, it might just end up being another tool belt that we can use to just simplify things for us in development. So no matter what end of the spectrum you fall on, whether it's full on Docker or just Docker in development, I think that Docker is a really valuable tool for all of us to learn. Now, I've mentioned containers, right? So now what exactly is a container? So Docker, I mentioned previously that containers and images are kind of the building blocks of Docker. So a container. So a container is more or less a virtual operating system. I remember the first time I heard about Docker, I asked, okay, so what is Docker? And the person explained it to me they said, well, it kind of lets you spin up kind of like a lightweight virtual machine. Now that explanation, it kind of makes sense. It helps you get kind of an idea around what the experience of running containers, but that's kind of a misnomer because really what's happening is a container, as I mentioned, it shares the operating system kernel of the host machine itself. So with a virtual machine, you have to partition the physical computing resources, but with a container, all you end up doing is you just end up partitioning the operating system resources. And then all the containers are free to share the computing resources that are available on the host itself. So, as I mentioned, containers share the host kernel. Now, when I create a container, let's say on a Linux machine for an example, that container gets its own file system, it gets its own process tree, it gets its own network stack. So inside the container itself, it doesn't know anything about the outside world, it doesn't know anything about the machine that it's running on. All it knows is it has its own version of file system and all these other operating system resources. And it's free to just do whatever it wants inside its own environment. Nothing outside impacts it, and nothing inside the container impacts the outside, unless you explicitly allow those changes to happen. Now, as I mentioned, so a container is really just an abstraction of kernel primitives. So on a Linux machine, there's two things called namespaces and control groups, and those are the two primitives of the Linux kernel that are used to create containers. So if you really wanted to, you could create your own containers just using those two things. But the value of using Docker or some other containerization platform is that all those nitty-gritty details are abstracted away from you, and you just have the end experience of running your containers, running your applications in containers, and it's much simpler. Now, I've mentioned Linux containers. There's also a concept of native Windows containers. So in Windows 10, they released operating system features called namespaces and job groups, which are pretty much equivalent to namespaces and C groups, respectively, on a Linux machine. And so on a Windows machine, you can run native Windows applications, right? So if you want to run like IIS or SQL Server on a Windows machine, you can do that running native Windows software. Now, I'm on a Mac talking about containers, and in particular Linux containers. So you might be asking the question, well, how is that possible? So the Unix kernel that Mac OS depends on, there's no concept of namespaces or control groups. So really what's happening is if I'm running Linux containers on a non-Linux machine, so whether I'm on a Mac or I'm on a Windows, because you can also run Linux containers on a Windows machine, then really what's happening is there's a very, very thin Linux virtual machine installed under the hood. And so that means, okay, on my machine, any containers I'm running are actually running inside the virtual machine and not on my actual operating system itself. I doubt that there would ever be a such thing as a native Mac container, because the primary use case for containers is running applications in production, and no one really runs applications in production on Macs. So I doubt that will ever happen. So pretty much on Macs we'll just be running Linux containers, and it works really well, as we'll see in our examples. So containers versus VMs. As I mentioned, so VMs partition physical computing resources, while and VMs have to virtualize all the computer devices to almost simulate not just the operating system and the environment, but the whole machine itself. While containers just partition operating system resources. So it's all much more lightweight, and that allows containers to dynamically share computing resources available. Now, I've mentioned, or before we move on, any questions about what a container is? No, makes sense? Cool. All right. So now, what is an image? So an image describes how my container should look. It's kind of like the template or the cookie cutter for when I want to create a new container. All of my containers are going to be based on a certain image. It's very similar to the concept of an operating system image, which is a file that describes the whole state of the operating system. Or for example, maybe even in cloud platforms like AWS, for example, you have Amazon machine images, which just say, okay, when I'm going to start a new VM in the cloud, I'm going to pick an image, and that image describes how my VM should look. So very much similar in the world of containers. An image says, okay, when I create a container, this is how the file system should work, this is the applications that I should have pre-installed in my container, and this is the process that should start off my container. So we can think of containers as instances of images. It's important to note that images are read-only, and we'll look more at that in the next slide. And it's also important to note that images are built from a special kind of file called a Docker file. And in our examples, we'll look at a Docker file and a simple example of how to build our own image. So in conclusion, images are more so build time constructs, and then a container is a runtime construct. Now, a slightly deeper look at images. So technically, images are composed of different layers, right? So in each layer of that image itself is itself its own image. So how it works is, so for example, maybe I have, I'm starting with an Ubuntu image, and I create an image from that to install maybe some dependencies and then put in some source code to run an application. So each step, each change that I make to the environment creates a new layer of the image. So what ends up happening is under the hood in Docker, all these are stored in all these different image layers are stored as different directories. But then what happens is Docker uses a union file system, and there's a couple different file system drivers that are used to pull this off, but it uses some sort of union file system to kind of mash these different layers together of the image. Now, the benefits of this, and furthermore, whenever we start a new container, actually each container has its own read-write image layer that's put on top of that image itself. So what ends up happening is in this example we have an Ubuntu image, for example, that has all these base layers, and then let's say I have multiple containers all based on the same image. Well, what ends up happening is, for reading purposes, they're all reading from the same file system and same directories. But whenever they make changes to the file system, those changes are persisted on this top read-write layer, and then so that any changes they make only impact them on this read-write layer. And then when the union file system mashes all these things together, they still see their individual changes overlaid on top of the starting base image itself. If that doesn't make a ton of sense, we'll see a little bit more about how that works in our examples. And the other benefit we get from that is whenever we have to rebuild a new image, Docker can cache all those layers, right? So if maybe only the second half of the layers of my image changed between the last build, it only has to rebuild those layers that changed rather than having to rebuild the whole entire image itself. Any questions about images? All right, cool. We'll move on. So real quickly, I want to call out Docker Hub. So Docker Hub is kind of like the NPM or GitHub of the Docker world. So in Docker Hub, it's a way to share images. So you can have multiple repositories, and each repository is a different image. So we'll look at a few major examples. So I can find just images that the average Joe Schmo like me created, or I can find official images. So for example, there's a Node image. So if I look at this, I can pretty much find an image for any version of Node.js I want to, which is pretty cool. And then these are actually all built on top of Debian. And then I can just pull down different versions of the images I need to, which will have the specified version of Node.js installed, along with some other tools, along with NPM, Yarn, and a few other things like that. So having these official images provide really great ways to start off. Just kind of a naming convention of image repositories. So official images, they just have a single name. Official images are curated by Docker themselves, but then any user-created repositories, like my repositories, for example, are all prefixed with my username. So Hayden BR / and then the name of the image itself. So Docker Hub itself is called an image registry, which is pretty much a remote place where I can store and fetch different images. Now, Docker Hub is only one example of an image registry. So if I'm, let's say, like an enterprise company, and all of our applications are running in containers, then I can actually host my own image registry, like behind a firewall somewhere that only people on our network could access. And then there's also other image registry services like on Amazon, on Azure, so you can host your own registry as well. And you can have private repositories in Docker Hub as well. So moving on, I'm gonna skip over this slide right here that talks about the Docker engine, just for the sake of time, because I want to get to the examples. But it's interesting to read. You can read on your own time later on about containerd and the container runtime and how all that ties together with the Docker CLI that you have installed on your machine. Pretty interesting stuff for those who are curious. So if there's no more questions about all this so far, I'm going to jump into some examples, because that's what we're really here to see. So any additional questions? Do you mind checking the comments?
Yeah.
Check if we actually have any viewers.
Yeah, we got a couple. One of the questions is going to wait till you got to the demo.
Okay.
But you can probably answer now. We'll probably lead right into it. If you've had any issues, if you use a shell, any other shell other than Bash, it looks like this user went ahead and downloaded it, and it seems to be okay. But for
was that you, Phil? Did you ask that question?
No.
Yeah. I haven't had any experience. So running on a Unix system using anything other than Bash, I'm not sure. So I know, like on Windows, I use PowerShell.
Don't you use Fish?
Yeah.
You use PNC.
I've used it as far as building images and running stuff off of images.
Yeah.
It seems to work fine with Fish anyway.
Okay, cool. So Fish works well so far. I wouldn't imagine there'd be huge issues, because it's more about the operating system rather than the shell that you're using to interface with it. Good question. Any other questions?
No, we were having a little bit of readability issues with the slides, but since we're about to head to the next part,
Okay.
I'll keep an eye and make sure they can read all
Cool.
the code.
All right. I am going to adjust my screen share real quick. I'm just going to share my whole screen. Cool. All right. Okay. Let me maximize this. All right. So first example is very simply, I want to run a container from the Hello World image. So whenever you learn a new technology, you must always run the obligatory Hello World example. So
can you make that, is it possible to zoom in a little bit more?
Bigger? All right, cool. I'll do that. All right. So if I want to run a container, it's as simple as Docker container run, and then the image that you want to run the container off of. So I can say Docker container run hello world. And this container is super simple. It just goes and it'll start that container, print out some text onto the screen, and then it'll exit. And this kind of the text just kind of explains what happened when you did that. So pretty much the Docker CLI talks to the Docker daemon. If the Docker daemon sees that the hello world image is installed locally, then it'll go ahead and start it up. If not, then it'll go off to Docker Hub or whatever other image registry that you've specified. It'll pull down the image, and then it'll run the container itself. Now, containers start with one process, and then whenever that process exits, the container itself dies. So this simple process just printed out some text, it exited, and then as soon as I finished with that, the container stopped. Now, that's a pretty simple example, so it'd be nice to do something a little more significant. So now, I want to run container run. I'll run an Ubuntu-based image. So this time, before I specify the image I want to run, I'm going to give it a few options. So first, I'm going to give it -i and -t. And what this does is the -i binds the stdin from the container to the shell that I'm running in, and then the T gives me kind of like a terminal inside of the container itself. So these are both used pretty commonly together. The easy way, pretty often we just stick them together like this for simplicity. And the easy way to think of the I and the T is kind of like interactive terminal. It's not exactly what it means, but easy way to remember what it does. And then you can also give containers names. So we'll just call this Ubuntu. And then the image I'll start from is going to be Ubuntu 16.04. So in this case, when I tried to run it, I didn't find it locally, so I could pull it down, and it pulled that image pretty quickly from Docker Hub. And as soon as it got that new image, all of a sudden you notice that my prompt has changed. Well, now I'm inside the container. This right here is the start of the container ID that I'm inside of. And so if we look, it looks like the file system that we're in, it looks like I'm inside of an Ubuntu machine. However, if I look under the hood slightly, so I see what's running, in this case, all I'm running is just bash itself, because that's a default command to start off the Ubuntu container. Now, if I was on a full-fledged Linux distribution, there would be a lot more processes running behind the scenes to make the operating system work. But remember, since the container is sharing the host's operating system, it doesn't need to worry about all that crap. Additionally, things that I would expect to be installed like Git or Vim, all these things aren't pre-installed. Because in containers, we only want to have installed exactly what we need. So I'll exit that out, and then we'll do a slightly more. Yeah. 1235. Okay, thanks. I'll do this real quickly. I'll do a slightly more significant example. So I can do Docker container run -it. This one I will call Nginx because I'm going to base it off of an Nginx image. Nginx, if you're not familiar with it, is a simple web server. It's similar to kind of like Apache Tomcat. So I can get this started. It's pulling down that image for me. But you know what? I want to do one additional thing here. I'm going to give it an extra command argument this time. So in this case, my server inside the container is going to be listening on port 80. Now, I want to be able to direct network traffic inside that container. So what I can do is I can give it this this -p command or the -p option. And so what that does is it allows me to specify a port on the host machine to direct traffic to the container itself. So I know, and I can check the Nginx image, and I know that it's going to be listening on port 80. So that's this 80 right here. Then for the host, I can choose any port I want to. So in this case, I'm choosing 8080, but I can just as easily choose 18,000 because why not? So I'll do that. And names have to be unique. So I'll call it my Nginx. So I'll go and get this guy started off. And it's running. So I'll come over here, go to localhost 18,000. And there it is, I've connected to my container. And just as easily as I started it up, and we can see the logs here, just as easy as I started it up, I can exit out of that container. So if I do docker container ls, I can see which containers are running, and I've got a lot of crap running here. It's irrelevant to today. But if I give it a -a flag like this, that will show me currently running containers as well as stop containers. Now that Nginx container has stopped, so I want to give the -a command for this example. So here's my container up here. I see that it exited about 20 seconds ago. Now if I refresh the page, it's gone. Now just as easily as I killed it, I can restart it. So I can say docker container start, give it the name or the unique ID of the container, and it looks like it restarted. And just as easily, it's back up again and running. And this is just in the same way that I did this with a simple application, I can do the same with even more complex applications. Any questions about containers so far? About running containers? All right, cool. So I want to take this to the next level. I want to do a slightly more significant example. So I promised Terry that I would do this. Now, here at Unboxed Technology, we use SQL Server as our database provider on the back end. Now, up until recently, SQL Server was only available on Windows. And but however, recently, they open source. Is it open source?
No, please no.
Okay. I might be. But now you can run SQL Server on Linux. Now, some people might be wondering, well, when is there going to be a Mac version? Because currently you can't technically run SQL Server on a Mac. But with the power of containers, we might not ever need a Mac version of SQL Server. So let's take a look at how we can use Docker to run SQL Server on Mac. So I've got my notes here because it's slightly more complex. Oof, where'd my notes go? Sorry. Let's see.
Do the users need to see this, or are you just copying something?
Yeah, I'm just copying something.
Okay.
Yeah. All right. So first thing I'm going to do is now we've talked about containers and images. There's a lot of different kinds of objects that I can work with in Docker. So Docker also has this idea of volumes, right? Because any data that's saved in a container will be persisted inside of that container. However, containers aren't meant to be long-term things. Containers are meant to be very disposable, very throwaway. So even though they'll persist any data, like this Nginx container, I could go back and I can say Docker container logs my Nginx. So I can go back and see any logs from that container. But as soon as that container is destroyed, which is inevitable, those logs will be lost. So anything that's important needs to be persisted outside of the container. So for that, I can use volumes. So I'll create a volume, Docker create volume, MS SQL. Docker volume create, my bad. All right, so I have this volume, and now what I can do when I start my container is I can specify, hey, you know what? Any changes made to this part of the file system in the container, I want those changes to be saved inside this volume, and this volume lives on the Docker host, which in this case, technically it lives inside of that small Linux VM that I've got running. So I'm going to copy and paste the command to get this container started because it's a bit heinous. All right. So here's the command. Quickly run through it. So Docker run. Docker run is the same thing as Docker container run. I'll have to put container on the front just to be explicit of what we're doing. This E flag right here is passing an environment variable to my container. So when I start this container, if I had a shell in that container, I would see this accept EULA as an environment variable inside of my container. Same thing with my password here. Again, this -p flag says, okay, any network traffic on port 1433 on the host, direct that to port 1433 inside the container. And then -it, we know what that does, and then I'm going to name my container right here. Now, this next flag I'm going to pass to tell my container to save its output, or to save any changes made to a certain part of the file system to this volume I just created. So I'm going to use the mount flag. For the source, I specify MS SQL, and Docker knows, hey, that it needs to use that MS SQL volume that I just created. And then the target says, okay, anything that goes inside var/opt/MS SQL/data inside the container, all this stuff is going to be persisted to the volume. So the value of that is when my container is destroyed, I still have all my data there, and then I can easily start up a new container and give it all this persistent data, and it'll start back from the point that the old container left off. And then lastly, here is the image I'm starting off with. Microsoft images are official, but since they have so many, they prefix them all with Microsoft. Yeah. All right, so I'm going to go ahead and run this. Sorry, I was doing this last night, so container names have to be unique, so I'll say Docker container remove, SQL, free up that name. So I'm going to restart this. There we go, so it's running. I'll wait for all this output to stop. Now what I'm going to do is I am going to use the Visual Studio plugin for SQL Server. Let me maximize. Ooh, too big. So I'm going to use this to interface with that SQL container that I just created. So I can do MS SQL Connect. I already have this set up. I'll create a new connection just for the heck of it. So I'll do localhost 1433. I'll connect the default database to start off with. SQL login, and username is SA. Password is super secure, and yes, I'll say my password. All right, connected. Okay, so I'm connected, right? Now to prove that I'm connected, let me grab this query over here. Yeah. All right, so I've got some SQL here. Starting off, I'm going to create this table called tutorial.db, or sorry, create a database called tutorial. It doesn't exist, and then I'm going to create an employee table, and then I'm going to just insert some basic data inside that table, and then we'll see if it works. So we'll highlight all of this, and Command-Shift-E to execute. And it worked. I hate the plugin that it gives me this text in orange-red color because it makes me think there was an error, even though there wasn't, but what the heck. So now I created that table, and we can see that, okay, these 4 rows were affected. So it looks like those inserts worked. So we'll count to make sure those worked. All right, counted 4, that's what it should be counting. And then I'll select that data just to make sure it was all good. And we can see that we were able to get all that data back. So that's pretty cool. I'm a bit new to this setup, so I'm excited to see how else I might be able to make use of this. So Terry, that means, maybe you can just stop using a Windows machine because you can just use a Mac and you can stop SQL Server.
It's tempting.
Yeah, I'm sure it is. Yeah. All right, now the value of using that volume is I'm going to go ahead, I'm going to stop that container. And then I am going to go as far as removing that container. So I remove that. That now, if all that data had been persisted inside the container, it would have all been lost. But I'm going to rerun the same command here. Make sure I'm disconnected over here. Yeah, I don't know how for real you can use the MS SQL plugin for Visual Studio Code. It's nice that you can do that, but it's a little bit finicky and a little bit annoying.
They have a new UI.
Yeah.
It's like SQL Server Management Studio for Mac.
Yeah.
It's got a different name.
Yeah, that's what Philip uses. What is it called?
SQL Operations Studio.
SQL Operations
Yeah.
Studio. Is it still in beta or is it like full-fledged?
It's still in public preview.
Okay, cool. So maybe one day I'll start using that instead. All right, so let me just go ahead and reconnect here. I'll connect to the container demo setup. Looks like I'm connected. And then let me, let's see, use tutorial DB. It's pretty cool though that the IntelliSense even works. So I'll use that, and then I'll go ahead and rerun my query. Oh, come on now. Oh. All right, so maybe it didn't work out exactly. I ran this last night and it worked. Oh well. Such is life.
Demo curse.
The demo gods are against me. Oh well.
So what exactly is a volume, and how does it differently persist stuff between different container sessions?
Yeah, so pretty much a volume says, hey, instead of saving, so like by default, any of these database changes are just going to be made, oh, hold on. I think I figured out why that didn't work. So by default, any database changes I make are just going to be saved inside the container, right? And like I said, so like as soon as the container dies, all the data you have is gone, right? So that's not very convenient, right? Because if you are developing applications, right, you might like at the beginning of the day start up your container, and then at the end of the day shut it down. And you don't want all of your changes to be saved just inside that container, because containers are meant to be thrown away. So the value of that is instead of changes only being saved inside the container, they're saved in an outside place. And so then what you can do is you can pick up that volume and you can plug it in to a certain point of the file system in any different container that you want to. So that way, like, important changes are being saved to the host machine itself, and then future containers can just pick up that data that's already been created.
So volume is just a data stored folder in your computer.
Yeah.
That can be picked up by any container.
Yeah.
Kind of like an external hard drive or network share.
Yeah.
Can multiple containers connect to the same volume simultaneously?
Yes, they can do that, and you can even control like read-write permissions. Because if you had multiple containers writing to the same place, then you would have issues. Yeah, sorry that example didn't work out completely, but it does work. I tried it last night and it worked. But yeah, the interested reader can go back on their own and figure out why that didn't work. All right, 12:50. All right, as I want to do 2 more examples. So next, what I want to do is I want to take a look at creating my own image. So I'm inside of this Bob is Cool project here. It's pretty much a stupid like Hello World app, but it's got a dancing banana, so it's a little bit cooler than just a simple Hello World. But what I want to do is, it's an Angular 5 application, so I want to create an image to be able to run a development server inside of my image here, all right? So we'll go through that example. And so a Docker file has a pretty simple syntax. So it's just a text file. It's got a few different special commands, and you use those to build up your image. So the first line of any Docker file always has to start with from. Now from, I have to specify a base image to start off from. So for this example, since I want to run a development server for a Angular application, I'm going to start off with a Node.js container. And I've got a plugin installed that gives me Docker IntelliSense here. So I'm going to start off with Node, and then if I just say Node, by default, it'll go out and it'll find the latest version of that image. But in most cases, you don't want to do that because then your images are going to be inconsistent. Because I could build this one day and I could be in, 9 dot something, maybe 9 dot, I don't know what the latest is, 9.2. And then if I run it again in a few weeks later, I'm going to be in 9.3, 9.4. And I don't want that, so I'm going to specify 8.9.4, which is the latest stable release of Node.js as of maybe a few months back. So this is a pretty good one to work with. Next, inside of a Docker file, I can specify things like environment variables. So I could say node environment is equal to development, and then when I start off a container based on this image, then I'll have this node environment variable already in my container. Now it's important to note that this Node.js image itself is based on a Debian image, so that will at times impact how you build your images or how you write your Docker files, because if I'm starting off with a Linux distribution that uses a certain package manager and I need to install some dependencies, well then that's going to impact which command I use to install and so on. And actually there's a special version of this. There's an Alpine version. If you're not familiar with Alpine Linux, it's like a super stripped down version of Linux. So if I want to have the smallest images possible, which is best practice, then I could use the Alpine image. I'm not going to use that for now because we don't have enough time to go over best practices in an introductory talk. Let's see. Sorry, I'm going to look at my notes for this one. Yeah. All right, so next, what I'm going to do is, now, if I go ahead and build my image just like this, then I'm just going to have a container that's running Node.js, and that's it. But I want to be able to run my container, or I want to be able to run my application from inside a container based on this image. So then what I'm going to do is I'm going to say copy. I'm going to say dot and dot. So the copy command, all it does is it copies, this is the source and then your destination. So this is really not a really naive way to get started, but it's a starting point. When I build my image, as we'll see in a minute, I have to give the Docker CLI a build context, which is like, hey Docker, I'll let you have access to this directory in my file system, so that way in case I need to pull like maybe my source code or some config files from my machine to the image, I can do that. So this is pretty much just saying, okay, what the end result of this is just going to be, okay, all this stuff right here in my current working directory, just stick it all in the container. Now I don't want exactly everything to go in, right? Because I would want to install node modules that are specific to this image itself. So I wouldn't want my node modules to end up in there. So, but you can actually filter what ends up inside of your image. So very much like a git ignore file, you can create what's called a .docker ignore file. And I can say node modules. And that way, when I build this image, that will keep my node modules from ending up inside the image, because I don't want that. Next, if I want to be able to run an application from inside here, I'll need to run command, and that'll just be yarn install. I know from previous experience with this image that the node image already has yarn and npm pre-installed. Next, I know that I'll need to expose a port on my container to the host, right? So for Angular development, it's port 4200. Now, technically, I don't even need to do this much right here, right? Because I'll end up wanting to do docker run and then -p, and then also maybe like something like 4200 to 4200 would actually run this container. But it's best practice. So yeah, I don't need to specify this line in order for this right here to work, but it's kind of like best practice. Docker files are not super long files. Maybe a super complex one might be 20, maybe 30 lines long, but that's it. So best practice is to keep them readable and keep them self-documenting, right? So if I put this line here, that notifies any future user of my image that, hey, my application inside here is expecting network traffic on port 4200. Lastly, I can, last thing I'm going to do is I'm going to specify a command to get started with. So I could say yarn start, which is just a command to, I'll say yarn serve. So this is pretty much the simplest example we can create of a Docker image. So I'll go ahead and run this. Let's see, that is over here. Let me zoom in here. All right. So if I want to build this image, I can just say Docker image build, and then I will need to give it a tag. So I'll tag it as Hayden BR, since it's my copyright username, and then I'll call it Bob is cool. And then I can lastly give that image a version. So I'll version it as Unboxed. The version itself can be anything you want. So when we use it here at Unboxed, and the typical use case is just to use like semantic versioning over here, but for this use case, I'll just call it Unboxed. Now, the last thing I have to give to this command is my build context, and most commonly, it's typical just to give it, okay, your current working directory. So that's going to send the Docker daemon any files in my current working directory, and then it'll be able to access those files and put in whichever files I choose into the image. So I'll go ahead and build this guy. Now, while it's building, it's important to note that each line in a Docker file creates a new image layer. So we mentioned before that images are composed of layers, which each layer itself is an image. And it's best practice to keep your Docker images to as few layers as possible. So it's going to install over here. Also, while that's installing, it's important to point out that maybe this step right here isn't the best thing I could do. Now, when Docker is building my image, it's going to try to use previously built layers when it's rebuilding the image, right? So when it goes through all these different layers, if it already sees a version of that that's built, then it's not going to rebuild it, which is super nice. However, as soon as it sees one line that's changed, then all the rest of the lines will have to be rebuilt, right? So, for example, right, because if there's like a change in, say, my package.json, which is coming into the image at this layer, well, it doesn't want to use anything that's already built because that might impact what the next layer looks like. So it's best practice to split up things a little bit better. So if we wanted to be a little more smart about this, I could say, well, on this line, just copy my package.json to package.json, and then I'll install, and then I'll copy everything else. So slightly better way to do things. All right, now that it's finished building, I'll go ahead and get it started with docker container run -it -p 4200 to 4200, and this was my image. Now I can specify when I run this container, I can specify a new command to start off with. However, if I don't, this command right here will be used instead. So if I wanted to override that though, I could say yarn start or maybe yarn build, and it'll run those instead. But in this case, I just want to do the yarn serve. So I'll get that started. Oh crap. Oh, you know what? The reason that happened is I need to make a directory to put all this stuff in. It's pretty much what this does is by default, it's putting me into the root level of the file system. So right here, I'm just making a new directory to put my stuff in, and then I'm just saying, okay, right here, when any other command after this workdir command is being done inside of this app directory. And then with this as well, when I start my container, it'll put me in that directory by default. So I could go ahead and rebuild that image, which is unfortunate that I have to do that. While it's building, are there any questions about building images?
I had a question on your layer, like you said, if anything changes, it has to be rebuilt. You put the expose there at the end. Is that a layer?
Technically, it is a layer, but it's not really making any change to the file system. It's just kind of like adding metadata to the image. So like, if I had to rerun this line, it's not the end of the world because it takes like a few milliseconds to pull this off. Yeah. But best practice is like you want to keep the things that change more often as far down.
So if like expose should be higher up.
Yeah, I could do that actually. But I don't know. Typically, I've always seen it put at the bottom, but I guess it would make sense to put it at the top. Yeah. I mean, it's pretty cheap. Yeah. Any other questions about images?
So when you do your work directory,
Yeah.
everything gets installed there.
Yeah. So that pretty much says, okay, from here on out, from every following line in the Docker file, all these commands are being run from inside this directory, right? So if I didn't have this, I would just be putting package.json in the root level of my file system. But now all this package.json is ending up in opt/app/package.json. And then from inside this directory, I'm running yarn install.
So could you not run from the root earlier?
I mean,
This is just best practice.
it's best practice, right? Because you don't want to like if you're serving an application from any server, whether it's inside a container or not, like typically you don't just stick all of your application files on the root level.
Yeah.
Yeah. Just to keep everything neat and organized. All right, so it's finished. We'll go ahead and run this guy. There we go. So it's building. Awesome. So now, I'll make sure that works. And there we go. There's my awesome application. Now, I just want to real quickly demonstrate the value of having these cached layers. Right, so I put in my package.json first, and then everything else. So that means that if I make a change to the source, I'll just make a simple change. We'll see Docker is cool. And then if I rebuild that image, it was able to reuse all these previous layers. So it didn't have to copy this stuff in again, say, okay, using cache, run yarn install using cache. And then when it hit this copy step, that's when there was a difference. So then I have to rerun the following lines. But these lines were all pretty cheap. Last thing I'll point out with this here is that I'm going to do one extra thing here. So the value of using Docker for development is you don't have to keep on like recreating containers anytime you make a change to your source. So what I can do is I can specify a -v flag like this, which is similar to plugging in volumes like we did before. So I can specify a directory on my machine to plug in as a volume to the container. So what I can do is I can say my working directory and then source, and I'll plug that into opt/app/source. I'll go ahead and rerun this. All right, so I can refresh. We see Docker is cool. Now the value of plugging in that source directory is I can come over here to my source files. I can change this. And when I save that, so the container is seeing I've got a watcher running on those files. So the container saw that change. And then it reloaded when I made that change, which is pretty cool. So you can expand this use case, which we've done here at Unboxed, to pretty much keep all of your dependencies inside of the image and pretty much avoid having to even install your node modules on your machine itself. So I think we will go ahead and wrap things up. Let me find my slides.
We do have a question over here.
Yeah.
Aaron was asking if can you only run one image locally at a time? He said he was running into swarm troubles when trying to run multiple servers and images.
So that's a different use case. So you don't run images, right? You run containers based on images. And so Docker Swarm is where, okay, you are running, so Docker Swarm is what's called a container orchestration tool, where you can have like multiple instances of an image running, and you can have like maybe like your front end containers and your database containers and your API containers all running. So that should work. Yeah, I'd have to see more details though. But Aaron has my email address, so just tell him to like email me and I can help him out later.
Okay.
Yeah. Are there any other questions? All right, cool. So just to wrap up quickly, what's next? So now that you've seen Docker and what you can do, I encourage you to go home and play with it a little bit. So the repositories I used for my slides and for the Bob is Cool app will be in the description of the video later on. So you can look at those, check those out. My demo notes have like a ton of other examples that I just didn't have time for today. So there's also an example of running MongoDB. There's an example of you can actually use Docker to shield your computer from a fork bomb. That's a fun example. Don't try that at home. If you do and it screws up your computer, it's not my responsibility. But it's kind of fun.
Shield it from a what?
A fork bomb. So you can run a fork bomb inside of a container.
It's a fork bomb.
A fork bomb is pretty much a process that continually spawns more and more children until it eats up all of your memory, and then your computer shuts down. Yeah.
So Windows.
The blue screen.
Yeah. So you've never fork bombed your computer?
Not on purpose.
Oh, okay. I've done it accidentally.
Oh yeah.
When I was in school, and then one time I did it on purpose just to see what would happen. Yeah. So if you run a fork bomb inside a container, it only impacts the container. So that's kind of a fun example. Next, there's this really cool tool called Docker Compose, which is kind of an abstraction of all these different Docker objects, so containers, images, volumes. This is actually what we use. Pretty much Docker Compose just takes a config file, and you give it a simple command, Docker Compose up, and then it'll start off all the containers with a certain specification for you. Because, you know, in reality, you're not going to always want to run all those command line, give all those arguments or all those commands in the command line. It's a lot to remember, it's a lot to type. So Docker Compose is a nice way to just specify everything in a config file, give it one simple command, and everything's up and running. This is what we use in one of our projects here when we're developing. Next, there's container orchestration. So one of the questions was about Docker Swarm. There's also Kubernetes. So if you've ever heard of Kubernetes, there might be some confusion of Kubernetes versus Docker. It's not really one-to-one comparison because Kubernetes isn't exactly a containerization platform. It's a container orchestration tool, right? So that's what you would use in production to say, okay, I want a minimum of this number of a certain kind of containers running and a minimum number of this kind of container, and you can have all of them running on multiple different servers. So when it comes time for running Docker in production, these are the guys you want to check out. So with that, are there any other questions? No? Awesome. All right, well, thanks for coming, guys. I really appreciate it. And we'll see all of our many YouTube fans. We'll see you guys next month.
Yeah,
Be sure to like and subscribe. Wait, no,
Yeah, like and subscribe.
So here, was it May 8th? Yeah,
May 8th.
May 8th.
May 8th. Awesome. All right, bye.
Laters.
Thanks. Yeah.